As we're concluding our medieval times unit, I have one last thing that we'd like to do. And King Arthur has hired us, if you're willing, to be scientists to test out a new weapon that he's designed called a flipper system. And I believe we know it as a catapult. He wants us to use the weapon. He wants to use the weapon to protect and then to capture castles. So he needs for us to figure out the best way to get a projectile into the castle. Not in front of it, in case it's fire, it would burn up our own people, but to get it into the castle. So that's your job, should you accept it, is to design the perfect flipper system to get the desired projectiles into the castle. What do you think?
Okay.
To go?
Yeah.
All right. Can you tell us about a system that you've heard about in science?
It's a group of things working together to make something function.
Okay, and then do you have an example of a system that you know about in science?
Yeah, the human body. It's a group of organs to make something function.
The solar system's a system where you can study one planet or all of them together, but it makes more sense to study them all together.
Another system is a car. You can study the batteries, tires, and engines alone, but it makes more sense if you study them all together.
One thing about the systems is that the whole thing and all the little pieces matter. You have to understand all the little pieces before you can understand the whole thing.
Okay, and any other systems that you know
The
about?
respiratory system.
Okay, the respiratory system. And that works as part of a system. And we want to take a look today at the flipper system that King Arthur wants us to work with and identify the parts of it so that as you're designing your experiment, you'll know what you're working with. This is the flipper base that we will use as part of our catapult. And the flipper stick, which has been made by a popsicle stick with two small pieces, and a popsicle stick that can be used to press down the flipper stick to ensure that you get it all the way down. And aluminum foil, this is a 10 centimeter section and a 20 centimeter section of aluminum foil that you can use to make the launch object, okay? And this is the angle brace that can be used also as well in the experiment. Okay, if we're going to work together as a team, we need to decide who's going to do what. Do we have someone who'd like to be the communication specialist? Julian, what will you do?
I'll start the experiment and I'll also ask the questions.
Okay, good. How about our equipment specialist? Elizabeth, what are you going to do?
I'm the person that go get some material that we're gonna need for experiment, and after we're done with it, I cleaned it up and put it back where it was.
Oh, I like that cleaning up, putting back part. That's great. Thank you. The procedure specialist. Stevie, what are you going to do?
I'll be making sure we follow every direction, not skipping anything.
Okay. He'll keep us on our toes. Okay, the data collection specialist. Sergio, what are you going to do?
I'll make sure that all the information written down is accurate and make sure that it's all written down.
Okay, we're going to count on you for that. Okay, observation specialist. That leaves you, Dee. What are you going to do?
I'm gonna observe how high and how far the object goes and make sure everybody's getting an equal part.
Okay, an equal turn. That's great. Okay, I'd like you to set about exploring the flipper system.
Go there. All right.
Let's try the other one.
I'm gonna try it.
No, I'm mixing them.
Stevie, you already did it, sorry.
You go, girl.
Go for it. Move it back.
Say, move back, move back.
You're good.
Systems depend on all the pieces working together. You can see systems everywhere. The kids in the class are a type of system too. Everyone has a different job. They're all helping to make the flipper system work. If you add them all together, you've got a flipper system.
With a system, you have to be careful. There are so many different parts. How will they know the right combination?
For the control experiment, first we gotta set up a standard launch.
How about 0 angle, so keep
Yeah.
it flat on the ground.
And
make it be all the
yeah, all the way in. And we should like
The large has to be
Yeah.
the large.
Yeah.
And I think, as far as I remember, we can only change one variable at a time. Until we try getting the test.
Which
Let's
variable?
try space. The standard lunch, let's do that first. All right, what is standard first? Yeah.
It's like a couple of times. See what it looks like.
Someone said you could only change one variable at a time. What's a variable?
A variable is a condition that can change from one experiment to another. For example, if you wanted to figure out how fertilizers affected plants, the variable would be different fertilizers. Everything else would stay the same.
Stevie said we need a standard launch. What does it mean?
You have to use the same starting place each time you adjust the angle or change the load. If you didn't, your results wouldn't mean anything.
Right there, because that way, if it goes up right here, she's in front of it, she might not get a perfect view.
Actually, she should stand right here, right next to it.
Right next to it, huh? You have a calculator, Elizabeth? Here, I'll do it.
What are we averaging?
What was the last one that we recorded?
99.
It goes 99
Yeah.
centimeters, right? Yeah.
Okay, and just average it.
Hey, Stevie, what do you say if we push it up closer since all we're measuring is the height?
Sure. Try like halfway, which is 75
Right.
centimeters.
Let me try it.
Please.
No, that- Okay.
73. Okay. 73, right?
Let's do 3 more times and then take an average.
Sounds good.
We used a big box.
Oh, yeah.
Yeah.
Okay.
55.
D, since it's not going all that high, maybe you just want to kneel down.
Yeah.
Like you're doing right now.
Somebody else want to try it?
Oh. 60. Just 60?
Yeah.
Exactly what are the point of the spacers?
To see how far, to see if it's gonna go like.
What's gonna happen when
Yeah.
the effect of the outcome?
What's that change? What variable is that changing?
The
far it
how
goes.
much you push down this
And that would end up changing?
the height and
Yeah.
And how far it
Length.
goes.
it goes.
Okay. Somebody else want to try it?
I don't understand the point. Well, it had to be like
That would
5.
be about 3.
That was 5.
Yeah.
The base is not over.
First, you look at each variable. Then you think of it as a race. And that's the beginning.
You have to start with the smallest object, then you test it, and that becomes your standard launch. Then all the other tests are compared to that one.
Okay, I'll just average it out now.
Hey, how's it going, guys? You getting the problem solved?
Yep.
Let me get down here with you, okay? What variables have you tested?
I'm glad to see the pennies underneath the flipper. I wondered how they knew how far down to put it.
Someone suggested to repeat each flip and take an average. That helps to improve the accuracy of the data.
You can see the importance of having everyone be assigned to a special job. These kids work real well together. Can you imagine the confusion if everyone tried to do the same thing?
Or that way.
That
way, yeah, so it faces.
What do you think, guys? Is it gonna go farther?
Oh, yeah.
Yeah, I think so.
Okay.
Guess not.
Whoa, Julian, interference.
No, but that roll, aren't we good to know exactly where it hit? Because
16.
we're trying to get it in the cap of that.
16. That's 666.
16 plus 100.
Gotta look at the.
All the way in?
Yeah. Oh,
No.
I can interpret that.
Maybe
Like
one?
maybe at 1 or something. Like 1 out.
Yeah, so it doesn't go so
Like
high.
one.
So it doesn't go quite so
Oh,
high.
Or we can put it at
Maybe-
1 and use the
maybe-
angles
maybe
at something
3 though,
different.
'cause
Okay.
then- But we gotta measure how high the castle is first. Yeah.
Well, he had an idea that we leave it at 1 and maybe use an angle.
That's what, yeah. I'm just saying, yeah, we definitely gotta keep it at 1.
Okay, yeah, go ahead and get the castle. We'll measure it and see how high. Okay, what about, okay, let's try down there, okay? We'll go down there with the castle, and bring the catapult this way, Dee.
No, but it doesn't matter. We don't need to get it in the inside. We just need to get it inside the castle.
Those, because we really already know that the longer or the shorter is gonna make it go farther, or higher.
So we just
try-
do the.
Just try 3 and then 4.
Just do
You
the
need to
first
do
one.
0. You need to do
The
0.
0 and the last one.
Okay, now we have to make the big decision, guys. Where are we gonna, you keep the information. Where are we going to place our catapult for King Arthur to get this into the castle? Let's talk about first what we've learned from it.
I think the variable about how far the flipper sticks out is the most important variable.
All the variables are important, but some have bigger effect than others. That's how the standard launch helps us to compare things.
Okay, guys, we've got to justify why we're putting the catapult right here. King Arthur isn't going to pay us if we don't know, if we can't explain to him why we're doing what we're doing. Dee?
We'll put it at the 20-degree angle because it won't go too far and it won't go too close. And if we put it at the other angles, it might go too far or too close.
Okay.
That's why we put it at the 20-degree
We
angle.
didn't choose to put any spacers because if we put spacers, it wouldn't go that far, and then without the spacers, it will go higher.
Okay. Sergio.
We're not going to. We're gonna put it in 1 centimeter in or out so that it won't go too high or too low.
Okay. Ready?
Keeps falling in. I think we just put
You can put a little piece of tape there.
Oh.
Roll it up into like a little guy or something.
Okay. Oh, I'm so nervous. A little drum roll. Okay.
And ready. And
I think a catapult should be put right next to the castle and chose the highest setting that goes the highest. That way, it can be thrown in with a better aim.
We should put the catapult as far away as possible from the castle. By doing that, we can protect our soldiers from the catapult.
I think we should compromise and put it between the 2 positions. That way, we can take advantage of the angle of the flipper system.
Do you want to measure the outside wall or the inner wall?
What do you think?
Outside?
It'll probably go in the
get the inside, because no matter what, the inside's higher.
No, but it doesn't matter. We don't need to get it in the inside. We just need to get it inside the
Measure
castle.
both.
No, just 1.
Go.
The outside one. No,
No, because it could hit the top of that when it would roll off, just to make sure.
but still, if it hits the top,
No, if
it'll
it
just
hits in
fall
here-
down and then just fall on the ground.
There's always a chance that it would go. You always want to measure the highest.
Yeah.
Just
Yeah,
like you
measure
always
the
want to
high
measure the
one.
lowest.
No, but you don't know if it goes like, if it's
Exactly, we don't
Under
know.
there, you wanna
That's
know
why
the
we measure
outside.
both. Well, it's not gonna hurt to measure both.
just Can I measure?
Yeah.
Centimeters or inches?
What do scientists use?
Just use centimeters because we
Centimeters.
already used
Centimeters, because they're
Yes.
more accurate.
Yeah.
The tape is
Maybe it's
doing
because
nothing
of the
for
tape.
it. It's the tape. Let's do it. When you think about it, we should put it at the
0.
the 0 mark, because if that's what we did the angle at, and that went exactly at.
Okay, so we're doing it at 0.
Okay.
Wait, how far did the 20 go? What was the average?
20?
It was
96.
Where's 96 here?
Right there
Then if we do it at 10, if anything, we should put it
at 96.
at 96 or closer. Ready?
Come on.
All right. Ready? Come on. Aim and fire.
Oh, so close. One more try. You can do it.
It landed short of the castle. Which variable would you change in order to hit the target?
No, it was exactly right.
Yeah, hit it.
It hit something.
Hit it right here.
This right here.
It bounced out.
So we change it to 76.
Justin was right. We had to measure the inside too.
Oh, yes. You were right. Huh?
I said it too.
You said it too?
Yes, I did.
She did. She did. I thought that was Elizabeth. Oh, well, because. Ready?
Aim. Yes! We did it! Okay, we're hired. I mean, we will now get paid for after all of our hard work. King Arthur will pay us.
Where's he? How many
Better.
pieces of
What will he pay us?
Yeah.
And maybe an A on your science project?
Oh, man.